So, a very good afternoon to all of you. As you know that we all have covered more than half the journey of this 7-day online workshop on the tricks of econometrics. And today, being the 5th day of this workshop, I feel delighted to share with you all that through this journey of econometrics, we have comprehended the basic intricacies of this area of econometrics, covering about principal component analysis, multivariate data analysis, basics of time series, and yesterday we covered binary dependent variable models, specifically logit, probit, and tobit. And today, we take the opportunity to hear Dr. Suparna Gangopadhyay, who shall be giving us an insight into the panel data analysis. We welcome you, ma'am. You've already joined us. Thank you for being with us today. And before I hand over the stage to you, I would take the opportunity to give a brief profile of you to the participants. Dr. Suparna Gangopadhyay, a distinguished academician, currently holds the position of Associate Professor in the Department of Economics and heads the Department of Statistics at Surendra Nath College for Women. Her academic journey is marked by excellence, having pursued her postgraduate studies in statistics and econometrics from Calcutta University, followed by an MPhil from Jadavpur University and a PhD from the University of Calcutta. With a rich teaching experience spanning nearly 4 years at Annamalai University and 7 years at the Indira Gandhi National Open University, Dr. Gangopadhyay has significantly contributed to the academic landscape. She has successfully led two UGC-funded minor research projects focused on derivative markets and the global financial recession. Her scholarly contributions are evident in her authored textbooks on mathematical methods of economics and for Netaji Subhash Open University. Dr. Gangopadhyay's research interests are diverse, encompassing capital markets, financial derivatives, nonlinear dynamics, industrial sectors, and women's studies. Her work has been published in various journals and edited volumes. She is an active participant in the academic community, having presented papers at numerous national and international seminars and conferences, as well as she has chaired various sessions. Additionally, she has delivered special lectures on statistics, econometrics, and financial economics at undergraduate colleges. So we welcome you, ma'am. And as we have been enriched by the previous speakers, we are sure to hear something very informative lecture from you as well. Thank you, ma'am, for being with us. Over to you, ma'am.
Am I audible? I think I'm audible.
Yes, I'm audible, ma'am.
Oh, thank you so much for giving me this grand opportunity to be with you and my respected organizers, professors of your university, Lucknow University, my respected participants, my dear participants. I'm really honored for getting this opportunity because I think I am still a learner. I'm not very erudite person, and I'm not stating you very new thing. I'm really a learner, and I want to learn through the interaction. Okay, so straight going on to my presentation. Now you see, today, let me present first. Just a minute. Have some patience. Okay. Is this? Please unmute yourself and say, because I'm in full screen mode and just running on slideshow. I'll be using board as well. So is it, can you see, please participant, my dear participants, can you see, respected participant, can you see the board?
Yes, ma'am.
So yes, the slides are okay. Okay, so my topic is, as Madam said, that an insight into the panel data analysis. This is a This is a very basic understanding regarding the panel data. As we all know, just now I'm saying in my room, and you're also perhaps seeing in your class or something somewhere else, and there are many electrical points which we are using, electrical gadgets we are using, having different watts, having different voltage, but having different panels. They are interconnected, but finally they are connected to a meter. And once in a month somebody comes from the, in our case from Calcutta CESC, I mean Electric Supply Corporation, they take the meter reading and we get the bill. That is the output we are getting. To the inputs, that means different types of gadgets having different watts, that means having different kinds of variables, they are interconnected, creating a panel. There is so much heterogeneity, so much variables, and day by day they are the watts are being calculated. So different time points, different units here, these are gadgets having different watts and different usages, that means different variables, all when interconnected yields me a different result, which I am seeing finally. And then struck me that this time the meter is high, so what to do with it? Which connection should I check? Which type of electric point should I revise? Go to Amazon and do some measures like this. Panel data analysis is just like that. You know, as a student of economics, suppose you undertake a work on poverty, okay, over different states, okay, and you take two variables, say literacy, and another you say the rate of unemployment over different time periods. Okay, now states are heterogeneous. These are cross-section units. Over different points means there are different time periods also. And variables we have taken, one dependent, that is poverty rate, say rural poverty rate, headcount ratio. Another is unemployment. Another is literacy. Now, what happens? Different time periods. If you run the OLS, because you have already done a class on ordinary least square estimation. That's I'm saying. If you run the regression analysis following the technique of OLS estimation, what do you find? The states are, you can arrange the states like A, B, C, D, pool the states, overall time periods, aggregate and get a result. There is interstate variation which you are not taking. You are, in a way, assume the states are homogeneous, which are not. Concept. I mean, that is, I think, not very useful. The panel data, instead, the panel data has some cross-section, deals with cross-section and time series issues. Takes into account the cross-section as well as the time series observation. Cross-section means what? That data may be collected from a number of cross-sectional units, say some categories like countries, states, districts, villages, individuals, so on and so forth. Time series dimension means the data, these for each and every cross-sectional unit, say state, say individual, they are being studied over some time periods, the same time period, say 2001 to 2010, like that. This time point may refer to year, month, week, nothing matters. So this is the panel data. Now, you may consider GDP growth, unemployment rate, money supply, interest rate, whatever. So I think what is panel? Is it clear? If you look at this slide, how the panel being arranged, you know, just a thing I want to note you that if you have, since I am in a full screen mode, if you had any query, you just unmute yourself and say your confusion. I will try my level best to clarify that point, okay? Please, otherwise it will be a dumb-like class. Because
No, ma'am.
in front of you, yeah, unmute yourself and ask queries.
Sure, ma'am, sure.
Okay, That will be fine for me because I can see any one of you. I just see the computer and my slides only, not in the Gmeet. You are seeing me probably because my video is on. If you want, I can put off my video mode. Sorry. So see how the panels are arranged. You know, say Atlanta. All Atlanta sample panel data set. Year 1981, 82, 83, 84. Done. Then Austin. Once again, follow the year. 1981, 82, 83, 84. Once again, Baltimore. Once again, the time repeats. So this is the panel. The times repeats. How can you do the OLS then? If you run the OLS, then Atlanta will not be considered separately as Baltimore, as Denver. Okay. So this is a sample panel set. Right. Now, before I switch on to my board, panel data, there are many types of panel data, right? One is long versus short panel data. One is balanced versus unbalanced panel data, and worst is fixed versus rotating panel data. Now, what is long versus, what is long panel data and what is short panel data? For short panel data, if I say my cross-section unit as N, capital N, which is usually being done in econometrics, then that N is greater than T. N is greater than T. Time period is fewer. And the reverse is for long panel data. So for long panel data, the number of time periods you are considering that exceeds your cross-sectional, N. Clear? So one is arranged, widely, another is arranged in a long manner. Clear? What is balanced and unbalanced data? You see the slides first. You see in balanced data, there is no missing 24, 2000. Just consider for person 1, I'm giving ID 111. Then I've considered person 2, 2, 2, 2. This can be longer. This will be longer. I'm sorry. I'm giving as citing as an example. The years are 2004, 2005, 2006. Again, 2004, 2005, 2006. Okay. Right. In unbalanced data, just a kind of interruption. My home network is disturbing today, so I have connected myself to my hotspot. So if I get disconnected, I'll be connecting you again. So in short panel data, 1, 1 and not the 3, 1. 2, 2, 2, only 3. Clear? That means what happens in a balanced point, each of your cross-sectional unit will have the same number of time series observation. Clear? In unbalanced, this is not so. Suppose I take an example. I will come to the slides later through my board operation, but see here, I for cross-section, that means state, just for a moment, consider T for time series. Similarly, XIT. Similarly, UIT. What is UIT? That is the stochastic input. But you are considering eta I. This eta I is very much specific to the farm's characteristic. Suppose in my previous example of where I have considered rural poverty rate with unemployment and unemployment and literacy, I've told you. So there you're not considering gender. But you know, gender may have an important implication on the regression. Okay. You are not considering, it may be so, but you have to control, now you have to include in some other way, otherwise it will be accumulated in your random disturbance term, disturbing your relationship. if you consider panel data, that will be incorporated in your eta I. I'm showing you how. Before I describe this structure, I mean panel structure, data matrix, right? Just a minute. Is the board visible to you? And is the mark visible to you?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, yes. Thank you
Yes,
so
ma'am.
much. So, what I was saying, sorry. Let me just adjust. Structure of panel data. How do I write the structure, right? You see, let me measure time over here and my cross-section unit over here. Okay. So what kind of time I have? What are the time periods? Time periods say 1, 2, 3, ... t. And what is my cross-section unit? The cross-section units are likewise 1, 2, 3, extended up to n. So say for 90, I'm considering single variable. Okay, just single variable. It's a bivariate regression, say. So 1981, this is state number here. For 1981, these are the states for which poverty is considered. Now, how do I write? For 1, the value is x11. For 2, the value is x12. That means state 1, 1982. State 1, 1981. The value of poverty. 1, 3, right? ... What will be that? This is x1t. Okay. Then what will be the next unit? I mean, Bihar, say this is x21. This is x22. The value. These are the value. Okay. This is x23. What is this? This is x2t. Right? Just a minute. Let me save the note first. Okay, fine. So finally, this will be for, say, UP, x31, x32. So this is the data matrix, x3t. And next, what will be this? xn1 to xnt. Now, we will calculate the mean. I mean, if I calculate, say, in this way, that means for state 1, what will be the mean? For state 1, the mean is written as, you see, x bar, which is not changing, it. The basic variable is it. If I consider one state and not considering other, and the variation over time, if I considered, then state is not changing, only time is changing. So I will write it 1 That means, I'm sorry. So I will write is 1. That means for state 1, time is changing. Okay. For 2, the mean is written as x bar 2 dot. 2 dot means for state 2, time is changing. In a way, finally, I write this as x bar n naught. Now, if I go by fixing time, and if I go by this way, then how the mean is say mean can be written x bar dot t, meaning time is fixed. Dot means which is not which is changing, which is free. That means states are free within across state variation. For 1981, you are taking the mean of poverty across states. So it is written as x bar dot 1. Up to x bar dot t. Clear? Your grand mean is x bar. Is the structure clear to you? Okay.
Yes.
Supposing, so once again, the thing which you need to remember is, you see, if you consider this way, this is the time series variation for a particular state. Once again, this is a time series variation for a particular state. That means within state variation over time. This is what panel says. And if you consider, if you go by horizontally, this is across between state variation. That is the thing you need to remember. So in panel data analysis, you have two opportunities. One is, at the same time, you can calculate between themselves what's happening within themselves, within a state or within a particular unit, what is happening. That means between estimator, within estimator, and of course then the total. That means you are considering two sources of variation. One is between state variation, another is within state variation. And if you sum up, if you aggregate, you get a grand mean. That means total mean or total variation. When I say variation, keep it in mind that I'm talking about variance. Sources of variation, two: within, between. That means within state variance you are calculating, between state you are calculating. That means over time you are calculating, across states you are calculating, and you just summing up the variance. That means at the same panel you are getting the state-wise estimates, overall estimates also. This part I think clear. If not, I will repeat. I don't have any objection.
It's clear, ma'am.
It's clear. If it is clear, okay. If it is clear, that is the structure. Sorry, that is the structure. Sorry. That is the structure I have written over here. Clear? And next, so what I said, there is a cross section, there is a time series where I varies as 1 to n, t varies as 1 to t. So panel, when we come to panel, it is YIT. Then it is YIT. At a single set you are considering I from 1 to t, t belongs to 1 to t. Clear? Okay. That is the within group variation. Within group variation means what I said, what I drawn in board, That means within state, between means bit over time period, and if you're summing up, it is the total variation. Now look, what I try to say, this I have done through Stata software. This is actually a fair, I regress. There is a data, of course, I draw the data from internet and airline fares, and where distance was my dependent variable, and fare is independent variable. I'm sorry. Fare is independent variable. I'm sorry. Fare is independent variable. Distance is dependent variable. And what I want to know that what happens in the fare structure over all countries. I took some countries. You say this is Atlanta. In one panel, you can have, if you have a look, you can see the variation. Is the variation clear? Only for, this is the internet data, but I estimated it through Stata software. Okay. It's not internet data. Data have been brought from World Bank. This state, World Bank data, I have drawn it from internet sources. That is what I mean to say. And there are 4 time periods, 1981, 82, 83, 84. And you see the graph, you know the interstate variation. Clear?
Yes, ma'am.
Okay. If you want to see it within, in a panel, not in a panel, just out overlay. If you want to see the graph in overlay manner, these are the lines. But you see your overlay graph, what happens? This is actually, you are mixed up. What's happening? Which one is higher? Which one has higher variability? You are mixed up, right? But you can do this also in case of pooled. Now we will move on to basic panel data model. But before that, once again, I want to use the board to show you that, because otherwise you can't understand the estimation process. Now, sorry. My panel data variable is XIT. This is my panel data variable. Now, this is my basic panel data variable. Right? Now, if I write X bar I dot, okay, that is, which is I dot means, as I said, over time, right? Your time is free. So I write summation XIT 1 to T. Then across statements. That means your states are free.
Yes, ma'am.
Right? Summation XIT by N. And your grand mean means you're summing it up. That means summation 1 to N 1 to T XIT whole divided by total number of observation. Suppose you have 20 states and 4 periods, then there is 80 observations like this. Okay. And let me see the time. It is 3:30. Okay. Okay. And your sources of variation. When I consider within entity variation, for within entity variation, total within entity, you can write it as summation or sources of variation. Another way of writing it as S, sources of variation, sum of square, though I can write it as S. Sum of square, just say S within x, you are taking a particular state. This is square term. That means your over t you are calculating, and what I am writing, xit, right, minus x bar I, your t is free then. Where? The variance. Clear? This is within entity variation. And if you take your all cross-section unit together, then just drop the I, because you're taking now all. So it should be sum of square W x x. I'm not writing I then, because I am sorry, sum of square, I have used the symbol as, just I've used the symbol as S, na? S, sum of square W x x, don't use I then, because you're aggregating, equal to summation I to n, summation 1 to t xit minus x bar I dot and square. So what is this? This is your sum of squares measuring within entity variation of a single variable x. Clear? Likewise, you can write your variance, you can write your covariance, you can write between. Okay, for between, you can, just for an example, if I take between, I write S B X X, that is total, between total. X B X S means summation total, because that is double summation. Then 1 to n, 1 to t, I am considering between. So x bar I minus x bar, it will be, since total I am considering, I'm sorry, whole square. And finally, if you add, you can write covariance. Then if you have another variable, say y, then x into y, that is the covariance formula. So I'm not writing, write it now. So stxx, finally, this is a derivation which I have to, skip. I'm skipping, I know, because of time, because we will have to go through estimation procedure, right? So I think this part is clear. And what I am saying, that panel data model unrestricted. So this is unrestricted. This is slide number 12. Okay. Unrestricted model with panel data. Can you see the slide, or I have to move on to?
It is visible.
It is visible. So
Yes, ma'am.
because it will be convenient, time will be managed. So you see, there are basically you can what was my previous slides? Okay, yeah, panel data models. Okay, there are basically, if I divide into two parts, unrestricted and restricted. What is unrestricted? You don't have any restriction on your cross section unit. Cross section units are restriction free. Okay, that means if cross section unit is treated separately for estimating a model separately, then it is a pure unrestricted model. You see there, if you can see yi YIT, I missed T. X prime IT beta I. Look, beta I is there, signifying you that you are considering the states separately, right? And then UIT, your random term. And then beta hat, you have done, you have done multiple correlations. So you know X prime, X inverse, X prime, Y is the formula. Which summation, X prime, X inverse, X prime, Y. In bivariate, that X prime, X inverse, this is a matrix. X prime, Y is also a matrix. So in bivariate framework, I write it at summation XY by summation XI square, right? And that summation sign, sigma, cap sigma sign, I have specified it at S. Clear? This is your within group estimation. Right?
मैम स्लाइड को फुल साइज कर दीजिए क्योंकि
why not I say you na. Okay. Can you see? देख सकते हो बेटा, देख सकते हो?
Yes ma'am, now it's more.
ऐसे ही बोल के रहना, हाँ, क्योंकि मैं तो तुमको देख नहीं सकती, मैं तो मेरा स्क्रीन को ही देख सकती हूँ, हाँ, क्या होना क्या नहीं है तो मेरे को एकदम नहीं पता, मेरा हिंदी भी उतना स्ट्रांग नहीं है, तुम बोल लेती हो कभी कभी, okay, that's nice of you that you have pointed it out. Now, okay, once again I'll do it, I will go. Board, right? Next page. The board I can, this board can be done into PDF mode also. You can, I don't know whether there is a facility for you to have my what I'm writing, but if there is an opportunity, I'll send it to you. Okay, no issues. Okay. I can save it in PDF mode after I finish the class, and I'll send it to you if I'm permitted, of course.
Okay, ma'am.
Yeah, and what they think for unrestricted model, right? For unrestricted model, I am write it as URM, unrestricted model, YIT as your panel variable, X prime IT beta I plus UIT. That is what, yeah, very good, beta. And this beta prime I is a vector, like you see, beta 1I, beta 2I. I think this is the coefficient vector. It is the coefficient vector, right? Coefficient vector, right? Okay. And what is your fully restricted model? In full restricted model, na? This is known as pooled regression model. Okay, you drop this restriction and you take your XIT prime, beta, no beta I. See, there is no beta I. All entities you are considering, for the first one, you have treated them separate. For the second, you are aggregating them. So you're considering all are homogeneous. No interstate variation. Your conditional mean will be X prime I. If you take the conditional mean, the expectation Y given beta. Y means YIT. Expectation Y given beta, it will be your just X prime IT beta. That beta I will be there. So straightway, it's a total case. So what will be if beta had then? Summation X I YI, no I. Summation Xi, summation XY, summation X square. That means the total variation you are considering. Clear? So in my earlier case, I am in the framework of within. Now I am in framework of total. So your beta hat will be S total, STXY, STXX. Actually, I am trying to give you it very lucidly so that you can understand. But you know, there you have two kinds of problem. One is endogeneity bias. Endogeneity bias means when your predictor variables and your dependent variables, they are interlinked, but you're not. That may be interlinked. You're not considering. They're being influenced by each other. Clear? That is your endogeneity. Your UIT and XIT may be correlated then. Okay. So this is your problem. And so sorry, these are the problems.
Excuse me, ma'am.
Yes.
You said endogeneity. Endogeneity refers to the relationship between disturbance term and dependent variable, right?
Right.
Okay, okay.
Endogeneity problem means,
Okay,
you
ma'am.
see, there may be, predictor variable and dependent variable, they
Yes,
may
ma'am.
be influenced by one another for some extraneous issues. Like the example I was stating, poverty rate and how your literacy can affect your poverty rate or say wage rate.
Okay.
Your male or female, if there is discrimination, considering discrimination is there, okay, if you don't consider female, gender as a variable, then there may be a relationship because male wage is higher, female wage is lower. If it happens, take it for granted now, that you're not considering. That creates a bias. That is the endogeneity problem. You're assuming that they are constant.
Okay, ma'am.
Clear? There may be there may be other factors. That means there may be your errors in variable like that problem. Other issues. I'm just taking one as an example. Clear?
Okay. Yes, ma'am.
So I have talked about a pooled regression model right now. Two types of model. One is unrestricted and another is restricted. And that restricted version, you can call it as pooled regression model. Clear? This is what I was stating. Problem of endogeneity. Second, problem of, if you have problem of endogeneity, then your estimate is biased. And that is what I was explaining. Clear? And that is also, you see, Bolo, beta, bolo. No problem, bolo.
As you have bifurcated the panel data in two things, unrestricted and restricted. Unrestricted we have covered, and restricted panel model is referred as pooled.
Pooled regression model.
Pooled regression model.
Yeah.
Okay.
This is, you can say it as constant coefficient model. You can say it as pooled regression model.
Okay.
Okay. You have a nickname. You have a good name. You have many more names. It's like that. Okay. And there is, shall I proceed? Okay. Yeah, the class I'm enjoying because you're asking questions, you're interrupting me, so I'm happy. And the third one is, what is the time? I have time, na? Okay. Error component model. Now, somehow you have to, you have to solve your endogeneity problem, because otherwise all will be accumulated in your error component, in a random error component. So do one thing, break up your random error. If I break up my random error, then I get error component model. How the random error can be? Because random error gets disturbed now for endogeneity bias. So do something. So that is a solution. Two types of error component model is there. One is one way, another is two way. What is one way? Now, see, there are cross section and time series issue. So if you break it cross section specific or time series specific, it is one way. If you can break it in both way, you will have two way, right? sorry. Now follow this. One-way error component model. UIT is the error. I break it as mu I and epsilon IT. Clear? What is your mu I? This is cross-section specific because you have taken I. This is one way. Another, either or relation. Another, lambda t plus epsilon IT. Epsilon IT is your random error, idiosyncratic classical error, and lambda usual shock. And lambda t is once again time specific error. So either if you are cross section specific, then your multiple regression, because I have taken matrix x prime it, not beta xit. Clear? And whenever you write now, I am doing it with k variables. Just within a bracket, give the order of the matrix. Clear? Otherwise, it will not be treated okay. So YIT, if you take cross-section specific, it is mu I plus x prime IT beta plus epsilon IT. And if your time series specific, then lambda t will come here. But there is a restrictions. Here you see beta over here, your slope coefficients are identical. But your intersection not. I'm coming to that. I will explain it. The estimation method in this case follow OLS. Now, if two-way error component, then you have the freedom or you have the methodology to break it in both ways: cross section, time series. Naturally, mu I plus lambda t. Lambda t is time specific. Mu I is cross section specific. So your multiple regression becomes like this: mu I plus lambda t plus x prime it, like blah, blah, blah. If I am on my college board, then I will definitely write the matrix, order. But here I can't because then I will be losing my time. So, the next. Is it clear? Any questions on this?
No. Ma'am, एक चीज क्लियर करनी थी बस.
Yeah.
आप जैसे हमने अभी देखा, जो हम एरर टर्म है उसको हमने डिकम्पोज करा, दो चीजों में डिकम्पोज करा. इट मे बी क्रॉस सेक्शनल थिंग एंड कंपोनेंट थिंग, एंड अनदर वन इज टाइम स्पेसिफिक. तो मैं बस इस चीज को थोड़ा सिंप्लीफाइड तरीके से आपसे एक चीज पूछना चाह रही हूँ.
पूछो ना बेटा.
It implies that the disturbance in our model, in our data, if I consider one-way error component structure and I consider the error, and which is if it is solely responsible due to variations in our entities.
Yeah.
So that is the upper
conception.
Yes, ma'am. And if in case we have data of the variable like GDP, and due to some, it may be due to any, because of anything, during
any shocks, financial data like that.
Yes, ma'am. But during the time period, there are variation in the data due to time. So that is the case second one.
That is the case second one. I mean, if you are constricted yourself in one-way error component, then either follow the first one model and then follow the second one model. Now, if I get time, this is a very, very good question. This is a question on model selection. A very interesting issue you have asked. If I get time today, I will definitely answer your question. I like to be. And if I don't get time, I will request Anamika ma'am so that I will send you the answer and request ma'am to give you.
Yes,
okay, this is a very, very nice question.
There was a related.
How do you select the model? That is the task of econometrician. Big question.
इसी से रिलेटेड एक क्वेश्चन था. अब मेरा जो सेकंड क्वेश्चन होता, अपकमिंग क्वेश्चन मेरा यही होता कि एज अ रिसर्चर एंड एज अ like to do justification with the analysis part and with the choosing the appropriate model. So a unbiased move will be either go for one way error component structure or considering the two-way error component structure. That
Yeah,
was my second question.
yeah. This question will be follow. This question actually follows from the first. Clear? To
Ma'am.
get the answer, follow my next units, which I am stating.
Okay, ma'am.
Because you have, so first of all, this is when I don't I have a theory. This is a research related question. So first of all,
Yes,
I
ma'am.
have the basic literature survey, that what's actually happening there. What see,
Okay,
if I
ma'am.
see that if I see that it is time variance is there, then I will move on to the second structure.
Second part of one-way
But,
error
but,
component
but
is.
I may be biased now. I may be
Yes, ma'am.
biased. So I have
Yes,
you
ma'am.
taken. I have to justify myself.
Mm-hmm.
Model selection, the part I am stating.
Okay, ma'am.
Then if again if I am permitted, then
Yes,
you can have
ma'am.
my phone number from ma'am. You
Okay,
contact
ma'am.
me. I will
Okay, ma'am.
definitely explain you over phone.
Thank you so much.
This is a are you are doing research?
Yes, ma'am. I'm a research
Ah,
scholar.
fine.
And
Okay, definitely,
currently,
definitely, definitely, I will answer. Definitely.
okay,
What's the
ma'am.
time now? 3:53. Okay, hurry
Yes,
up.
ma'am.
Hurry up.
Okay, ma'am.
I will answer. I will answer. What's your name? Because I'm not in the Google Meet mode now.
Manisha.
Manisha, you are from where?
Merit.
Merit. Nice,
Yes, ma'am.
Manisha. And everyone else, please come up. Okay, please come up. Because I'm also a learner. I've stated. Okay. So the error component, you can break it up. One way error component, that is the main issue. Fixed effect model. There are four types of breakup. Two basic models. One is fixed effect, another is random effect. Fixed and random. These are the two major estimation process, followed by the, I mean, on the basis of the model you have built upon. Okay. I am going on to fixed effect and random effect in detail. But fixed effect model, there are two type: one way error component fixed, two way error component fixed. In random effect also you have one way error component random, two way error component random. Now what is fixed? In the fixed effect model, Manisha, please listen. Fixed effect and random effect, and everyone
Yes.
also. These is the most important issues. In the fixed effect model, the cross section or
Mm-hmm.
time series, cross section or time
For the
series,
time series.
right? Or not both,
Mm-hmm.
are treated as the coefficient of dummy variables. You know why? So that you have the opportunity to learn what is happening in each state. And these dummy are that means when you consider in Andhra Pradesh, other states are zero. When you consider Bihar, other states are zero. So you get the result for on Andhra Pradesh, you get the result of Bihar separately in a panel, in
Mm-hmm.
your estimation procedure. Not the fact that you're taking them separately, running OLS. It's not the issue. So they become the part of the interceptor. That's why it is called least square dummy variable model. I'm coming to that. And in random effect model, what's happening? All errors are combined to the random disturbances. Random disturbances means, stochasticity. Clear? Okay. So, so let me now move on to. I will give you the example also. Fixed effect model. Okay. In each of these, you get within estimation, between estimation. I'm coming to that. But consider the fixed effect model. You have the intercept. Basic model is this. I've written it at 2 because I have already used the first model. So A01 plus A1 X1T plus U1T. Okay. Now you include a dummy variable. So if I mean, that means if you use 1 for Andhra Pradesh, other for 0, it becomes like the equation 2. Clear? This is what is least square dummy. Sorry. And for two-way, you're allowing your cross to vary over your time. That means, you see, this when it is I is 0, it is intercept, and similarly A2I T1T. So you have to know that how you incorporate your time dummy. So one is the dummy cross section, one is the dummy time. That means your regression equation now shifts over time. That means your technology, your external shock, all are incorporated in the two-way model. Clear?
Yes, ma'am.
Okay. Before I go on to random effect estimation, before I move on to random effect estimation and within estimation, between estimation, let me show you one thing. Let me give you one thing, that where is my board? Yeah. Sorry. Let me take my board first. Like, take a model. Okay. Fixed effect. Okay. First, let me finish the fixed effect in a proper way. Fixed effect model. Okay. Take, say what I say. What I say, that my wage W IT equal to alpha plus say beta education IT plus epsilon IT. That means set of workers over the years who have some wage and with the with their level of education from school. Clear? Now you see what happens here, that if my education is 0, then alpha you are getting, the amount of wage you are getting is alpha. Clear?
Yes, ma'am.
So alpha can be stated as subsistence wage. But
Yes,
you know,
ma'am.
you're holding as I was saying, that that there is a difference between male and uh,
Female.
female wage. Okay, female wage. And if you run regression, what is the regression technique? Regression technique I will show you. You can have for fixed effect regression for male workers, your slope same, regression for female workers, regression line for female workers. There you are measuring education, and there you are measuring wages.
Wage.
So your slope same, but uh, intercept differs. Okay, but there a different kind of problem can arise. What? Suppose 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 if you pulled it together, all observations, if you all observations, what happens? This is a fixed effect. If you pull observations all together, that means Argentina, Bolivia, like this, you are pulling it together, getting more observations. It may so happen that your slope differs. That means this is the regression line you may get, by pooling. regression pooling. This is a misleading result. That is why I am stating that in a fixed effect model, if I say the fixed effect model, I am writing it as, for fixed effect, W equal to, say, alpha 1 D1I plus alpha 2 dummy variable 2 plus plus alpha n dummy variable n t plus epsilon I t. When dit equal to 1, that means you are taking the first cross-sectional unit and all other are 0. Clear? Now, as I find that there may be some researchers like that. In this case, what is my testing of hypothesis procedure? If your state hypothesis, null hypothesis, your null hypothesis can be then, because you are dealing with intercept dummy. You have learned dummy. Okay, so my null hypothesis will be alpha 1 equal to alpha 2. That means all dummy I am stating, intercept, alpha n, all are alike. Clear? And they are not equal to 0. That means there is variation. Obviously, my test statistic will be clear. And if this F, what is the formula? The formula is R square pooled minus, I'm sorry, first of all, R square F. R square, difference between R square, you know R square? In bivariate, it is ESS by TSS. Multiple correlation coefficient or coefficient of determination. Measurement of good fit, right? Just to give you an idea. So R difference between R square pool, R square F minus R square pool, whole by, I don't know whether you have written, you have learnt it or not, 1 minus R square fixed effect whole divided by the degrees of freedom n minus k. N, total number of observation. Here I have to use both n and k, right? Number of variables. This is a in panel, na. In panel, what we are doing, as I have shown you the data matrix, na. What we are doing, it is 3 dimension, na. Variables, country, time.
Time.
But when I am writing like Argentina, 2001, 2, 3, 4, Bulgaria, that means I am reducing 1 dimension. It becomes 2 dimensional. Clear? That is a kind of leveling. Otherwise, you can form a data matrix then. Clear na? Okay. This is follow F with degrees of freedom. You know, how do I write degrees of freedom? Numerator, denominator. Now, what is your decision rule? Your decision rule is, that means what happens, you know, if your F prime, R square F means computed R's from estimated fixed. I said R square pool means computed R square from pool regression. N means what? N means number of intercept, then it has become the number of intercept. That means your cross-sectional unit is your number of intercept. Now, if you add your number of intercept, nothing, because your other variable 0 to state 1, other variable 0 to state 2, that way. So if you add them, you get n. So that is, either you can consider it as a number of intercept, that means number of parallel lines, or you can consider it as a cross-section unit. Nt is your total number of observation, and there I have written the k is your number of variables. So if your F prime, I mean computed F, greater than the tabulated value, based on the degrees of freedom, then null hypothesis will be rejected. Clear? If the null hypothesis is rejected, what will you say? You will say that fixed is preferred. Clear? So take the pool regression and take the fixed effect model. Compute the F. If your F, now if your F is greater, then fixed effect is preferred. Clear? But fixed effect has some, is this part clear to you? Okay. Assuming that it is clear that their fixed effect is preferred means all states have some different intercepts. If it is clear, the intercepts are not equal, that means states are not equal, wages are different in different states. If you consider that and differential effect you're considered is preferred, then there is a limitation. Using two, if you use too many dummies against degrees of freedom, then there is a dummy variable trap problem like this. Okay. So may I be permitted to move on to my slides again?
Yes, ma'am.
And there is how much time is left? Oh, fine. It is 4, 5. Okay. Now within estimation. Before move on to the random effect. Within estimation, what it does? This is actually, this deals with deviations from group or from time period means, I'm sorry, group means or time period means, whatever. If I say group means, or variation within each entity, right? So my model, one way error correcting, okay? One way error component model. Yit equal to beta 0 fixed, huh? Mu I plus beta 1 x1 xit, sorry, plus epsilon it is the model. So if you take the mean, it becomes y bar I am taking the mean, beta 0 plus mu I plus beta 1 x bar I plus epsilon bar I. Clear? Again, you can take the average of it across individual. I mean, first time, then across individual also. Then I will be dropped. So what can I do? Taking average across individual, what I get? I get y bar equal to beta 0 plus beta 1 x bar plus epsilon bar. My assumption is what? Summation mu y equal to 0. If any question, that means now you can see, if you have any question, you can Please, you can unmute. Now what you can estimate? There, you know what you can estimate? You can estimate beta 1. Actually, in the model, you can estimate beta 1. You can estimate beta 0 plus mu I. Is it? Isn't it? That means my beta 1 can be estimated. My beta 0 plus mu I can be estimated, but not beta 0 plus mu I separately. Jointly estimated. But not separately. Clear? And what is then my beta hat? My beta hat is then once again, because I have used this to you. Summation xi by clear? Like bivariate? Clear? Any question? So fixed effect estimation, what it does? This explores the relationship between your predictor and outcome variable, predictor and outcome variable within an entity. Clear? And how it does? By removing the effect of time invariance on a. So it is time invariant. Remember, it is time invariant. That means we can assess the net effect of the predictor on the, because time is out, time invariant on the outcome variable. This is the reason for why the slope coefficient is the same, but intercept differs. Okay? Because cross-sectional differences are being considered. So please remember, fixed effect is time
Invariant.
Clear? Okay. And what I was saying, and being considered as part of the intercept. So this is the important thing. Now, within effect has some problem. What kind of problem? Disadvantage, what you can say. I mean, if the within cluster variation is, suppose if the within cluster variation is large, it's okay. But if there is a limited variation within cluster, then it doesn't work well. Clear? And since it doesn't include time variant variables, like I give you the example of gender, there may be ethnicity, then you cannot use this kind of estimation procedure. You can use between regression model, but between regression model, it is rarely used. It is not in vogue, rather, you can say. Clear? And least square dummy variable, I said that each considered as dummy. Okay. Now, then I think I have one way, I have two way. Oh my God, my mouse is creating problem. Just a minute. Just a minute. What happens? Oh my goodness. What happens? Just a minute, please. Oh, fine. Sorry. Yes. So then I will move on to the random effect model. Let us consider this model. Yt equal to alpha 0 plus alpha 1 xit plus vi plus epsilon it. Clear? And then this vi is this is a component which is unobservable. Clear? This is random error term. This varies between groups, that means between states, but not within the cluster. And there is epsilon it, that is, this is the idiosyncratic error. That means that can vary over group, over time. So two part. One is random error part, another is your idiosyncratic error part. Now this is the assumption, your standard assumption. That means here this is the classical error 0. For expectation vi square, that is variance of random error part is sigma square v. Variance of idiosyncratic error is sigma square e. This is homoscedasticity. And these vi and epsilon it, these two random error part, these are not correlated. So autocorrelation is not there. That means epsilon it and vj, these are not dependent. Clear? Epsilon it, j is, so this covariance is 0, this covariance is 0 also. This is non-autocorrelation. And group correlation is also avoided. So these are the, have you done GLS? Generalized least square, GLS? If you don't, then I'm not going into that.
मैम OLS पर कराए but GLS नहीं किया अभी.
Yeah, na? Okay, then drop this idea. I'm just then before okay, I can give you okay. I can give you the idea. Not GLS, but okay. I can with the help of that example, no wage example, I can write. Okay, suppose your random. Sorry. Just a minute. Let me reconnect the board. Some issues have appeared. Na? Just a minute. Yeah. Okay. You can see the board once again.
Yes, ma'am.
Hello.
Yes, ma'am.
For random effect.
Yes.
Wait. WIT. That is the previous example. That means education being regressed on wage over different states and over different time periods. Now I have idiosyncratic error. So alpha 1 plus UI say plus beta education IT plus epsilon IT. Okay. And this alpha for the time being, write it as just only alpha 1 plus beta education for simplicity plus epsilon t. Okay. Now I'm sorry, not epsilon, write this. I have to give a new alpha 1 plus mu 1, say, just a minute. Take this two. Take this two. Okay. Take this two. So write it as VI, or say I write this as VI. VI. Okay. Where your VIT, sorry, where your VIT equal to UI plus epsilon IT. Now, this UI is cross-section specific. Clear? Error component. This is cross-section specific error component. And epsilon, that means individual specific. This is idiosyncratic error, which means this is both time and cross-section specific. Clear? So I'm breaking down that means it can vary over time, it can vary over cross-section. Now, if you like this, then your variance of VT, VIT equal to the sum of two variance, covariance is 0. So you can write it as sigma square E plus sigma square V. I'm sorry, that is not V, that is epsilon. Sigma square epsilon. Your VIT has 0 mean, constant variance, because it is homoscedastic. I have already shown in my slides. But you know what happens? This can happen. These VIT and say some other time period, VIT, VIS, that may be correlated. That means composite error term of a given cross-section unit, I is same, at two different time points, they may be correlated. That means your VIT and say time point is S, clear, may be correlated. There is a problem. That's why random effect is being considered. What is mean? It means, it means your composite error term of a given cross-section unit at two different times are correlated. Okay, then what is the correlation coefficient? Then we have to find out the correlation coefficient. If you find it tough, please do stop me. The correlation coefficient is rho, which is your sigma square u, plus sigma square epsilon for all t not equal to s. Now, yes, any question? Now, suppose this correlation structure is ignored. and we estimate the random effects model by OLS. I'm not considering the correlation. I'm just applying OLS. Clear?
Hmm.
Then your estimators will not be efficient. It will be inefficient because there is a correlation. There is a correlation then. So how OLS can be applied? That is why GLS is applied.
Okay,
Clear?
ma'am.
This is the basic idea why GLS is applied. OLS is inefficient.
Okay, ma'am.
Clear? And
Clear, ma'am.
yes, that is the basic thing actually. Actually, you stated na that ma'am we haven't done GLS. So
Yes, ma'am.
I thought it will be better to give you the idea that why OLS will not be appropriate. Why GLS
Okay.
is appropriate. Clear now? GLS
Clear,
is
ma'am.
there your variance covariance matrix becomes different because there you
Mm-hmm.
are considering covariance, not 0, 0, 0, 0, 0. And your basic beta hat GLS is x prime omega inverse cap omega, x prime omega inverse x whole inverse x prime omega inverse y. And that omega, I mean in between omega, there is a matrix. That is the variance covariance matrix where covariances are not 0, 1 row, 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 1 row, row, like that. Clear?
Yes, ma'am.
Now, you see, there may be the cases where random effect also may not be, appropriate. I'm not going through it. But one thing, what to choose?
Yes, ma'am.
How to choose between,
Fixed
say,
effect and random effect.
random effect. Then I think I will have some time to answer your query because this is 4:30. Let me try. Now, for suppose there is a hands-on idea, not, before going on to before performing any test.
Mm-hmm.
What happens now? We have software like eViews, R, LIMDAPE, Stata, whatever we get data, and whatever software I am using, either MATLAB, either R, either LIMDAPE, either Stata, either R. Okay, I am applying and get okay, Hushman, run, Hushman, get the result. If it is rejected, blah, blah, blah. But you have to think,
Hmm.
भाई व्हाट्स हैपनिंग भाई व्हाई एम ये करते क्या है ये लोग करते
Yes,
क्या है क्यों
ma'am.
हम इससे करते हैं ना सोचना पड़ेगा ना रिसर्च मीन्स थिंकिंग ना
Mm-hmm.
तो सोचना पड़ेगा रे बाप हाँ आई एम रिसर्चर आई एम नॉट एट ऑल अ डूअर कि मैं कोई कंप्यूटर इंडस्ट्री में तो नहीं काम करती हूँ कि जो बोले वो करके दिखाए
Haji.
इसीलिए
As
इकोनोमेट्रिक्स में इतना डिमांड है ना
all softwares are there, and I
या
think there is a difference. This thing only creates difference between a human and machine.
अब this is yet another an interesting question yeah you can say rationality is the basic difference but
Yes,
now
ma'am. Yes,
now
ma'am.
you can to some extent you can insert the rationality on robots also but still that will be continuing and for that more rationality in human brain is being considered because human neurons that is acting there but you are the basic thing you are the human
Yes, ma'am.
okay interesting anyway leave it. Now, the hands-on idea is that I don't know how I'm making you bore or not. Perhaps participants are, I don't know how much participant left. Okay, so where I am choosing between, so I have to choose between REM and FEM. Now,
Yes, ma'am.
hands-on idea is that REM you consider suitable before going on to any state when your N is large. N is large. That means wide. N is large, T is small. What is the intuitive explanation? That means as your intercept alpha I in REM, that is a random variable. That means it must be allowed to assume a wide spectrum of values, even if I consider the wide spectrum of values over minus infinity to plus infinity. This can be possible when n is sufficiently large. So when n greater than t, REM is suitable. But REM doesn't or may not be suitable satisfactorily where n is small. That means if your n is small, what happens? You may have less number of dummy variables. Then FEM is suitable. Because if you have more dummy variables, you may fall into the multicollinearity problem, introducing more dummy in your model. Here, so this is the intuitive explanation. But what will you do? Actually, when you perform a test, we have to prove it. That's why statistical test comes. And that is known as Hushman selection between, that is the selection between REM and SEM.
Hmm.
And the test is Hushman test. Clear?
Clear, ma'am.
I have already stated you that REM is not preferred if your composite error term, that means I have written it as VIT, gets correlated with any of your explanatory variable of the model. It may be a possibility. So Hushman, that means if your XIT gets correlated, it's a problem. So Hushman adopt a test basing on the idea that if there is no correlation between your VIT and your explanatory variables, say, then your OLS and GLS both can be consistent, but OLS is consistent but inefficient. But if correlation exists, then OLS correlation exists, then it creates a problem in OLS. Then what you do? Suppose there are two estimators, FE and RE. So Hodgman, what he stated, your null hypothesis is both beta hat F, that means fixed effect, beta hat obtained for random, consistent, but beta hat F is inefficient, consistent but inefficient. What is your alternative hypothesis then? Your alternative hypothesis is beta hat F is consistent, right? And efficient also, but beta hat random is inconsistent. You got my idea? One second. See, both F and R are consistent, but beta hat F is inefficient. And your alternative is F is considered as well as efficient, but random is inconsistent. That means here what we do, we are actually testing null hypothesis. Random effects are consistent and efficient. Against random effects are inconsistent. As the fixed effect is always, you see, fixed effect is always consistent. Yeah. In both cases, fixed effect you see are consistent. In both case, effect, this is consistent. So matter is efficiency or inefficiency.
Okay.
Matter is efficiency and
inefficiency.
right, efficiency. So you can reduce it to that. Clear?
Clear, ma'am.
It is not on consistency. but the efficiency. So what I can write that, oh my God, always for null, oh my God, let me switch on to the black again. For null, you can write random effect are consistent and efficient also against your alternative random effect are inconsistent. So you are reducing it. So Hoshman actually takes, say, a pattern Q hat equal to beta hat F minus beta hat R on the as the basis for test statistic. Okay. Now the test statistic is Q prime. I'm not going through the derivation because I don't have time. Q prime अब तक तो ठीक थे, अभी भाग रहा है, टाइम छूट रहा है. Beta hat F minus variance beta hat, comparing the variance only, because efficiency relates to the variance, you know. So I'm not stated. I'm sorry. Beta hat R whole inverse Q hat. Clear? How this has come, how this has been written, I have to avoid, sorry, I have to avoid because this is 438. So anyway, you can understand that this takes the variance square, I mean difference of variance square inverse the Q hat, the original F statistic, where K is your number of explanatory. Since it is a square, so definitely square means, first of all, you know your basic state statistics is your parent distribution. Normal distribution is your parent distribution, you all know. And if you if any of the normal distribution, some other kind of distribution, I'm sorry, is derived on the basis of normal distribution, where some parameter, depending on the parameters, the parametric value are known to you or not. Clear? That is T, chi-square and F. If you take the square of the normal distribution, dividing by degrees of freedom, then you get chi-square. So here you take square, so it's a chi-square distribution. Clear? Chi-square with degrees of freedom, K. Clear? Now REM suitable, I'm sorry. Now, sorry. Now, what is your, what I said? Chi-square. Now, what is the decision rule? If your chi-square is greater than your theoretical value of, I mean book value, table value of chi-square at the chosen level of significance, say alpha, and the chosen degrees of freedom you have here K, we reject null hypothesis, right? If you reject null hypothesis, then REM is consistent. I'm sorry. Null hypothesis, then I'm sorry, rejection. Now, rejection means if fixed effect is consistent. If you do not reject, then you prefer random. Rejection of Hoshman test means your fixed effect is preferred. Non-rejection of Hoshman test means your random effect is preferred. Okay? Like, so this is the model I have explained to you. This I said, this is the Horstman test, that is chi-square. This chi-square is known as volt chi-square. If W less than your critical value, that means tabulated value, then your random effect is preferred. Clear?
Yes, ma'am.
Clear?
Yes, ma'am.
Okay. Okay. So, this is the basic idea. Fixed effect estimator always works, but at the cost of avoiding effect of time invariant regressor. Clear? For that, random effect is needed.
Inconsiderate.
This is the takeaway, right? I think for dynamic regressor panel data model, I don't get opportunity for my time constraint, so I drop it. Dynamic panel means, you see, there is a lag. If your y is lag, clear. YIT depends on UIT. That means alpha T epsilon IT, and hence on alpha I. That's true. Your lag depends on alpha I, and that's why on YIT. This is a problem. For this, another kind of estimation methods are required, not OLS. Okay. So, yet another thing I need to point out. I think that will, what you said, that suppose uh, suppose you organize your data, right? You have organized your data. Just a minute. First, as a researcher, you organize your data. Okay, this is the first thing you have to do. And you start modeling. You first start with pooled and think critically. What are the potential problems do I have with the observed and unobserved heterogeneity? That means there may be some missing variables, as I said, gender, that has not been taken into account. There are other issues also. And then the second stage, think about the source of heterogeneity before running the regression. That is, whether the source of heterogeneity comes from cross-section or from time series. If you think after COVID that there are lots of financial crisis maybe there, or after global financial recessions, the shock may pass from one country to another, then time series variables you can consider. I'm not saying you just now. Thank you. Thank you. Just okay. So the next stage, source of heterogeneity, whether it is entity based or time based. Clear? So group effect or time effect. If I think that individual heterogeneity is captured in the disturbance and the individual, effect is not correlated, I presume, with any regressor. What I said, individual heterogeneity is captured. Individual heterogeneity is captured where? In the disturbance. And individual effects are not correlated with any regressor. Then I try a random effect first. Clear? If the heterogeneity can be dealt with individual specific intercept, I repeat, if the heterogeneity can be tackled with individual specific intercept and the individual effect may possibly correlated with any regressor, then it's better to try a fixed effect, right? Now, if each individual group has its initial capacity and say they share the same disturbance variance with you may say other individuals, then also you can apply the fixed effect. If each individual has its own disturbance, has its own different disturbance, a random effect will be better. Why? This can figure out your heteroscedastic disturbance. Next stage. Next stage is your testing procedure. Okay. First, you conduct a formal test on individual or time effect, or both. If the null hypothesis of your LM Lagrange multiplier test is rejected, I haven't gone through it because I don't have time, just I'm answering your question. Then a random effect is better than the pooled OLS. If the null hypothesis of F is rejected, our fixed effect is favored over OLS, pooled OLS. If both are not rejected, then fit the pool. I repeat, formal test to examine individual or time effect or both. If the perform a Lagrange multiplier test. If the null hypothesis of the Lagrange multiplier test is rejected, REM is favored, okay, than the pooled. If the null hypothesis is rejected, then a fixed effect is favored over pooled. If they're not rejected, fit the pooled DLS. Now, the Hirschman. So, REM and FEM both are favored. Because LM test rejected means REM better than pool. LM test rejected means FEM is favored than pooled. So, you have reduced it to pooled vis-a-vis REM or FEM. Clear? Pooled vis-a-vis REM, F rejected, REM. Pooled vis-a-vis FEM, F rejected, FM of, LM, rejected, Lagrange multiplier, rejected, FEM. Then what about REM and FEM? Madam, I'm 1 second in a confusion. Then Hirschman. Hirschman test is conducted when both hypotheses of F test and LM test all are rejected. If the null hypothesis of uncorrelation between individual and regressors is rejected, go for robust fixed effect, otherwise stick to a random effect model. And finally, what your question? One way or two way? In which way I go? Suppose you have a strong belief that heterogeneity involves two cross-sectional, two time series, or one cross-section, one time series. 2 means TWO2 cross-section, two time periods, one cross-section, one time periods. Try two effect model. You can double check if you really organize your panel data in a true manner or not. You can try if your N and T are large enough. Do not try a two-way model for a poorly organized data. If you cannot organize your panel data panel data properly, don't go in for pooled effect. Don't go in for two-way effect. Clear? So I'm here. Any question if you have, and my namaskar, and thank you for patient hearing. Until I stop hearing.
Dear participants, any queries from your side?
No queries from my side though. As ma'am, it was very interesting session, and I will clear one thing that this was the first time I read about panel data, so I didn't have any doubts. As currently I am dealing with time series data, and I was curious about panel data, and this session, like I even didn't expect that I will get a chance to read panel data like this, and this session was totally इंफॉर्मेटिव और आपने जिस तरह से सारी चीजें क्लियर करते हुए चले, मैं तो शुरू से ही अपने छोटे छोटे आपको बीच में इंटरप्ट भी कर रही थी.
That made the session quite interactive, because ma'am has said very early in the beginning itself that do ask some questions, because she could only see her slide. So it became as if she is actually teaching, and the interaction from the participants made her lecture more informative and more interactive. So thank you, Manisha.
अनामिका मैम, मैं कल भी आपको ये कहना चाह रही थी, but I didn't get a chance. Thank you very much. आपने इस प्रोग्राम को ऑर्गेनाइज किया, एंड आई गेट टू नो फ्रॉम प्रोफेसर दिनेश कुमार, एंड एज आई एम फ्रॉम द डिपार्टमेंट ऑफ इकोनॉमिक्स, चौधरी चरण सिंह यूनिवर्सिटी. सर ने हमारे फॉर्मल ग्रुप में डाला था, एंड मैं एकदम से गई सर के पास कि मेरे को ये ज्वाइन करना है, वो चल नहीं रहा था. आपको फिर सर ने कॉल किया था.
राइट.
तो मैम, मतलब एक ही बून जैसे, मतलब एक आशीर्वाद के जैसे, मतलब ये बहुत अच्छा प्रोग्राम है.
मैं ये कहूंगी मनीषा, फॉर अ कीन लर्नर एंड अ ट्रू रिसर्चर like you, I think this platform was must, and I think in that case I should really give my heartfelt thanks to all the speakers for each day session. और आज का सेशन मैम की डायनामिक प्रेजेंटेशन के साथ, और मैम आपने जिस तरह से उसको पावर पॉइंट प्रेजेंटेशन के साथ माइक्रो टीचिंग विद दैट वर्ड विंडो जर्नल ऐप के साथ आपने इंक्लूड किया मैम, दैट मेड योर डेलिब्रेशन मोर ऑगमेंटेड. So the learning actually became more augmented. We got enhanced to our learning as well of panel data, because मैम आपको पता है मॉर्निंग में मेरे पास कुछ कॉल्स आए थे जिनमें कि कुछ रिसर्चर्स ने एंड पार्टिसिपेंट्स ने कहा कि उन्होंने टाइम सीरीज पे बहुत काम किया है, बट दे वांट टू हैव अ गुड इनसाइट ऑफ द पैनल डेटा एनालिसिस, एंड आई वाज हैप्पी दैट दिस टॉपिक वाज इंक्लूडेड एंड वी गॉट अ स्पीकर लाइक यू मैम. And when I read your profile, I was really, I was impressed basically. And I should say that, ma'am, आपने जिस तरह से एग्जाम्पल से सप्लीमेंट किया, आई थिंक इसीलिए शायद कोई भी हमें अब क्वेरी नहीं मिल रही, बिकॉज मोस्ट ऑफ द क्वेरीज वर रिजॉल्व. और आपका REM और FEM, आई थिंक दीज वर सर्टेन कैची एरियाज which will hover in our mind, and it has given an insight to read more. And as you said that yes, anyone who wants to interact with you or want to learn from you can share your number. So like as if they ask, I'll share the number with them. And
definitely, because I have to constrain myself in time. I thought I should go to time. Idea of that will be for themselves, that will be more handy. And I am also very much grateful and thankful to all the participants, and of course all of you, that I get this opportunity, and through the question Manisha asked me and that I handled.
Manisha has been asking and has been resolving her queries in each of the sessions. So Manisha has been a very active participant. So yes, I really will say that your supervisor or your teacher of your university have really given you a good area of research and an inquisitive mind, which is very much necessary for a researcher. You have that inquisitive mind, and even to ask a question, you need to study. You just cannot ask any question like that. So when you are asking, it showed that yes, you are doing a real research and you are into this research area with all those intricacies which are perhaps being resolved by these sessions, I think so, Manisha.
Yes, ma'am.
Yeah, you can go through a book like my teacher, Econometrics in Theory and Practice by Panchanand Datta sir. You can You can go through by that. You can go through Baltagi even, econometric analysis. You can go in panel data. You can go by Woolridge even.
Woolridge, yes.
Woolridge, there are 2 books on Woolridge. Both of them, not the introductory. One is black book, that is, data, carrying out data analysis and along with all panel data, time series, everything. And another is econometrics itself.
यस मैम, एक तो जो आपको ब्लैक वन वाले बोल रहे हैं इंट्रोडक्टरी इकोनोमेट्रिक्स अ मॉडर्न अप्रोच, आई हैव दैट बुक एंड उसमें वही आपने जैसे बोला उसमें सारी चीजें हैं, बट अभी आप बता रहे थे कि वुलरिज का दूसरा एडिशन है जिसमें पैनल डेटा,
क्रॉस सेक्शन एंड पैनल, दैट डील्स विद बोथ फॉर क्रॉस सेक्शन एंड पैनल डेटा.
Okay.
And I think Ma'am Jyoti Kumari Sharma has also raised her hand.
Yeah, of course.
Do you want to ask him a question?
Jyoti? Yeah.
Ma'am, good evening, ma'am.
Yes.
Ma'am, actually, the thing is that I want to go in for a revision. और आप जिस तरह से समझा रही थी, ma'am, if you want, I can speak in Bengali also. There is no problem.
Yeah. কোনো সমস্যা নেই যদি তোমাদের if your organizer permit, I don't have any objection.
Ma'am, actually,
हिंदी में भी बोल सकते हो.
हाँ ma'am, I can speak in six languages, so there is no problem, ma'am.
Fantastic, Jyoti.
This is an official platform, no?
Yes.
Yeah. So, ma'am, actually, I wanted to go in for a revision. So, I just wanted to meet you, ma'am, since you are from Kolkata itself, and it's a nearby place from my side. So, ma'am, can I come and meet you and then?
Why not? Why not? Definitely. I will be very happy and very eager to see you. Come to my college. Give me just call. I think Anamika ma'am will give you my phone number.
Sure.
And
Yes, ma'am.
if I'm permitted, I can I can write my phone number also, email ID also. You can contact me. I'll be fortunate. I will love that.
Yes, ma'am. Actually,
We will
I'll
have a
be fortunate,
discussion.
ma'am, to have a revision and etc. Ma'am, actually, econometrics has gone away from my mind. Actually, the thing is that it's my specialization. But 12 years without econometrics in colleges itself, ma'am, you can understand what kind of a situation I'm facing at that time.
Think econometrics as your basic dal, chawal, etc. Because it's a must-do thing. It's not your dal, chawal. ये क्या है? ये देखो, एक अच्छी तरह दाल बनाने के लिए सोचना पड़ता है ना. सब दाल तो अदरवाइज एक जैसे होता है. रेसिपी होता है. रेसिपी को समझो, सीधा हो जाएगा. और जब लैपटॉप में जाओगे,
वो तो समझना है, पर कोई समझाने के लिए भी हो मैम तो बहुत अच्छा लगता है ना. कोई मिल जाए तो बहुत अच्छा लगेगा.
Okay.
Ma'am, we have one more participant, Komal Pal, who has raised her hand. Komal, आपको कुछ पूछना है?
मैम, बस मुझे मैम से बोलना था कि वो आपका लेक्चर बहुत औसम था मैम. फर्स्ट टाइम मुझे इंग्लिश में कोई लेक्चर इतना अच्छा लगा.
थैंक यू सो मच
मैम. मतलब मैं इंग्लिश लेक्चर्स देखती थी, बट मुझे कभी भी उतना परफेक्टली नहीं समझ में आया जितना आज मुझे समझ में आया. थैंक यू सो मच मैम. मुझे बोलना चाहिए कि मेरे अंदर ये कॉन्फिडेंट लेवल आया कि हाँ, ये लेक्चर में समझ सकती हूँ. Thank you, ma'am.
Thank you, all of you, all participants. And once again, from the core of my heart, thanks to Suparna ma'am for being with us and for sharing such informative lecture in your data analysis. Thank you so much. So participants, do fill the feedback form and fill it accurately, because this is going to be, a data for your e-participation certificate. Thank you so much. And I shall be sharing, the recording as such, as you all have been requesting in the group. That will be shared at the end of the workshop. So we are working on that. And till that time, do join us and